Hi, um, this is video 2, and I don't know how many videos it's going to take me to make this rain catcher game. We're making this. Let me restart it for you. So it's a game where you have drops going down the screen. You've got a bucket at the bottom, and you've got to catch as many drops within a certain amount of time. I think this one's set up for 10 seconds. Let's start the play. Click. There's my bucket. There are my drops. There's my countdown timer up there. Ooh, so exciting. Okay, it's over. My score was 5. My high score was, well, 5. I restart and I can play again, try to get a better high score. I think I'm going to do it. Yay, I got 6. High score of 6. Okay, so that's the gist of what we're doing. In the last video, we made the drops. We created a class so that we could have drop objects going down the screen. Here it is. This is our, oh, wait, ignore this. We haven't got there yet. Class drop. It does 3 things. Basically, it renders itself. It draws an ellipse. It moves that ellipse down the screen, and then it checks to see if it's gone off the bottom of the screen, and then gets put back up at the top. So it looks like we have a lot of rain, like infinite raindrops. But it's really just 5 that are sort of being recycled every time. And then we created 5 drops, and we used the methods. Okay, so now we need to make that bucket at the bottom. So, as you could probably guess, I'm going to make a class called bucket. Oh wait, don't have parentheses after class names. I always do that. Okay, and every class needs a constructor. And, did I spell that right? Constructor. All right. Probably gonna need what? An X and a Y and a width and a height for that little paddle thing. And we'll need to take these temporary variables here and put them inside of the actual object when it's born. X equals X, this dot Y equals Y, this dot height equals height. Okay. Then we also want to give it a method that will actually draw it to the screen. I usually call it render. You can call it whatever you want, display, show. And that draws the rectangle. This dot X, this dot Y, this dot width, this dot height. Okay. And that's all we need for now. Let's create a bucket. Let me just test to make sure no errors. Okay. Let's create a bucket, and then okay, let's go up here and we're gonna say bar bucket. Okay, we declared it. Now we're going to initialize it. We're gonna birth the bucket. Bucket equals new buckets, and we need to give it our x, y, width, and height. So I'm going to say, well, the x is going to be affected if it's going to change with the mouse position. Well, we got to start it with something, so I'm going to put it in the middle. Width divided by 2. The height is going to be, let's see. We want it a little bit off the floor. Let's say if it's 40 tall, I'll put it at, and I'm in rec mode center. I should have pointed that out. I put myself in rec mode center because that's how my brain works. Height would be, let's see, the Y would be the height, which is the very bottom, but minus, I don't know, 20, because let's say we're going to make the width is going to be 80 and the height's going to be 40. That seems a little thick. Let's try that. Well, we actually have to draw it now. Now let's go bucket dot render and see if it works. There we go. Yeah, that's a little thick. I'm going to bring that down quite a bit. Let's make this 60 and make this 20, which means we need to make this 10. I just want it to stick to the bottom, but I don't want it to go halfway out the bottom. Let's see if that's better. That's better. Yeah, we can do that. That's doable. Okay, great. We got a bucket. We got a bucket. Now, what are we gonna do? Now we want it to move from side to side. So we want its X to be the same as its mouse X. So where would we put that in the code? We could put it here. Yeah, sure, we could just put it here so it's always there. So mouse X instead of right in the middle. But then why am I asking for an X? Well, we need to put it somewhere because what if the mouse isn't actually on the screen when the game starts up? So we need to give it a place to start. So maybe this isn't the best way to do it. We want it to at least appear in the center as a sort of like the game is started and it starts in the middle, and you know, if someone hasn't moved the mouse or done anything, they'll understand that there is an object, there is a thing that exists there that they need to deal with. So what I'm going to do is I'm going to leave it there, and I'm going to adjust it. I'm going to change the X when the mouse is finally moved. So over here, I keep my classes at the bottom. There's a function called mouse moved, and it only fires when the mouse is actually moving. So this would be a good place to change the bucket position. So one of the great things about objects is that you can access all this in here, this dot blah, this dot x, this dot y, you can access those and anywhere in your program. So I'm going to say on mouse moved bucket dot x equals mouse x. And let's try that. There we go. Now it's working. There's something I want to add to this. I don't like that it's going off the screen when my mouse goes off the screen. I want it to stop right at the side and not go any further. I think just that's better gameplay. So I could do an if statement that checked to see if I was so far from the wall. But there's also this function in in P5 called constrain. It's under math functions. Constrain, where are you? Constrain. It sort of caps it. You can only go between this number and that number. So you constrain, you give it a value and you give it the number that you're wanting to constrain, and you tell it how low it's allowed to go and how high it's allowed to go. So let's do that. So we're going to constrain mouse X to, remember we're in rect mode center, so it'll be this side. We don't want it to go past there, so it will be 0 plus half of the width, so basically half of the width. Sorry, not this, bucket dot width divided by 2, and then the other side will be not quite to the full width, so width minus bucket dot width divided by 2. Width minus bucket dot width divided by 2. And if you weren't in rect mode, this would actually kind of be simpler. It would just be 0 and width minus bucket dot width. But I have to do it the hard way, I guess. Let's try that. Nice. So now it doesn't go any further than each side, no matter where the mouse is. Okay. Yeah. All right. Getting there. Let me save. Save. Okay. The next thing is now we want to catch these raindrops. So let's start with the counter. What we want to happen is for every time the bucket object is in contact, whenever it hits or captures or wherever you want to think about it, we get a point. So we need to make a counter. So var counter, it starts at 0. Okay. And so the question is, where do we check to see if the drop has hit the bucket? So let's think about this. How do we know the drop has hit the bucket? Well, if the drop has a y value, we're really just working on the vertical here. So as soon as the drop's y value is close somewhere, we get to decide on the top or the middle or the bottom of the bucket, then the counter goes up by 1. So let's say as soon as the y value is equal to or greater than, or something like that. So do we have the bucket checking to see if it hit the drop? Well, then the bucket would always constantly be having to check for all 5 separate drops. But if we put the code inside the drop class, each drop is checking itself to see if it's been captured by the bucket. So let's do something like this. Reset, we've got a reset function for drop. Now we're going to give it one called, I'm going to call it caught. No, caught. And what it's going to do is it's going to say if this dot y is greater than or equal to bucket dot y, and that's going to be the middle of the bucket. We can change that later if it doesn't feel quite right. Bucket dot y, then counter goes up by 1. And then let's console the counter to see if it's working. Okay. Alright. And watch the console. No, it's not working. Oh, we never called it. We created it. We never called it. We never called it. Oh geez, I stacked these like that. I'm gonna do this. I'm just gonna put them down here and drop 1 dot hot, and then play. Okay. Okay, so if you're noticing here, I'm getting way more points than I should be getting. Yeah. And the reason for that, do you know? We're just checking to see if it's past the bucket, but it's going to keep on going past the bucket as long as, well, we're checking for the midpoint because we were checking for that the y, which is halfway up. So as long as it's between the y, the midpoint, and whatever point where it resets itself, it's going to be there for a few frames. It's constantly incrementing the counter. So how do we fix that? Let's see. What we wanted to do is hit the bucket and not count itself anymore. So what we can do is we can, and this is a handy trick, is give each one of those drops a variable called alive, so it knows whether it's alive or it's dead. So if it's caught, it's dead. And we don't have to pass it. Alive will be true or false. We don't have to pass that in into the constructor if we, I mean, we just want them always to be true in the very beginning, so we can just set it here. This dot alive equals true. And that way, on the caught part, only if they're alive are they going to increment the counter. Only if they're alive. Okay, we'll do that first. We haven't actually made them not alive yet. We'll get there. But we'll say if alive, oops. Well, oh, let me back up. Let me do this in a different order. Once they're caught, get rid of it. We'll leave that. Once they're caught, this is the caught part, we're going to say this dot alive equals false. And then we're going to wrap this whole thing in an if statement, or actually we can just add it on here. If this dot y, if it hits the bucket, and this dot alive equals true, then make it false now. Now you're not alive anymore because you hit the bucket, and increment the counter. Okay. Now, we still have another step, but let's just make sure this is working. Okay, I should just get 2 there. 1, 2. There we go. 3, 4, 5. Okay, great. Problem is I'm not going to get any more than that because I never made them alive again. But I got all 5 of them. So at some point we want them to reset and be alive again. And we have this reset function here that pops them up to the top when they get down here. So why don't we just use that to, as when they get reset back up to the top, they're alive again. So let's do that. This dot alive equals true. Let's see how that works. Okay, so I got 1, 2, 3, 4, 5, 6. Yes, I'm past 5 now, so we know it's working. So there we go. We've created the bucket. We've constrained it. We've got it counting. We've got a counter now. This is great. So I'm going to stop this video here. And the next one, let's see, I think we'll probably, how do we set a countdown timer? How do we do that? And then have it stop and give us a score. There's a lot of other steps we have to get through, but this is good for now. All right, goodbye.